So in this lesson, we're going to talk about modeling and solving, really more focusing on solving two-step equation. So we're given this model of 5x, 1, 2, 3, 4, 5, plus 4 equals negative 6. 1, 2, 3, 4, 5, and 6. So what is I need to isolate x. What's the inverse operation of plus 4? Minus 4. Don't forget to balance it on the other side. 1, 2, 3, 4. These 0 pair out. And so we are left with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 negatives. And we have to divide it into 5 x's. So how many negatives will each x have? I believe it is 2 negatives for every x. So the answer is x equals negative 2. Again, we do like checking our work. Let's substitute the x with negative 2 plus 4 equals negative 6. 5 times negative 2 is negative 10 plus 4 equals negative 6. This is negative 6 equals negative 6. Check mark. So we're going to be practicing more on these. This time, it's more of you writing the steps and modeling. And now we're actually going to draw this on a number line this time. So in this model, we have two x's. First I'm going to write wait, let's model. Do you want to model it first or you want to write the equation? Let's model it first. We have two x's, we have negative 5, and we have positive 9. What is the inverse operation of negative 5 plus 5? I balance it on the other side, so I add 5 on the other side. Now I cancel by doing 0 pairs. Anything? Nope, nothing here. So we have 5, 9, 10, 11, 12, 13, 14. We have 14 positives. I need to divide them into two x's. So I mean each x will have 7 positives. So let's see if this is correct. Let's do the algebraic step. So algebraic step. So let's write the equation. What's the equation? The equation was 2x minus 5 equals 9. That was our sum. So we need to add 5 on both sides. Now we need to cancel out 0 pairs and simplify this. 2x equals 14. I have 14 positives. How many x's are there? 2 x's. I need to divide these 14 positives into two groups. This cancels out. X equals 7. Hey, same thing. On the number line, we have 7, 8, 9. So, whoops. Oh. So let's put 6 in this. Let's put 7 in the center. Let's put 2 integers to the right of it and 2 integers to the left of it. And 7 is equal to 7. So open dot or closed dot, it is a closed dot because it's equal to that. Next one. So in this model, we have negative 2x plus 5 equals 7. So let's model it first. I need to isolate negative 2x. What's the inverse operation of negative 2x? What's the inverse operation of plus 5? Negative 5. Let's balance it on the other side. Does anything cancel? Yes, they do. Cancel 0 pairs out. So what we have left is we have 2 positives, and we need to divide them among negative 2. So that means 1 positive for every negative x. But again, we're solving for x. So with your algebra tile, you're able to do the opposite of. So opposite of is this. So each x equals negative 1. Let's show it with algebra tile. So we have 5 minus 2x equals 7. What is the inverse operation of 5? Minus 5. So we minus 5 from both sides. Cancel 0 pairs, simplify, negative 2x equals 2. And let's look at them all. We see that. I need to divide these two positive into negative 2x. So we divide both sides by negative 2. This cancel, x equal negative 1. So let's plot this on the number line. The two integers to the right of negative 1 are 0, 1, and two integers to the left of it is negative 2 and negative 3. And is it open dot or closed dot? Since it's equal, it is a closed dot. All right, next one. So in this example, we have a negative 1, which is equal to 3 positives and negative 4x. So we need to isolate x here. How are we going to isolate x? What's the inverse of plus 3 minus 3? So I subtract 3 on both sides. I cancel 0 pairs out. Blah, blah, blah. And now I have 4 negatives. I need to divide them among these negative x's. So there's one negative for each negative x. But again, am I solving for x or negative x? I'm solving for x. So I flip it around. X equals 1 or 1 equals x. Let's choose our algebraic step. So I need to isolate x. What's the inverse operation of 3? Subtract 3 on both sides. This cancel. You have negative 1 and negative 3, so it'll be negative 4. Negative 4x. So I need to divide these 4 negatives among 4 negatives. What's the inverse operation of multiply? Divide by negative 4. Divide by negative 4. This cancels out. So x equals 1 because 4 negatives divide by 4 negatives. Opposite of a negative is positive 1. So x equals 1. Looking at our model, it is correct. Let's use our number line to see this is correct. Is it going to be open dot or closed dot? Closed dot because it's equal to 1. Next example. In this example, let's write the equation before I mess it up. It's 4x plus 2 equals negative 6. So let's model it. I need to isolate x. What's the inverse operation of plus 2? Subtract 2. Let me balance it on both sides. This 0 pairs out. So we have 1, 2, 3, 4, 5, 6, 8 negatives. We need to divide it among 4 x's. That means each x will have 2 negatives. Let's do an algebraic step and see if this is correct. So what is the inverse we need to isolate x. What's the inverse operation of plus 2? Minus 2. Let's subtract 2 on both sides. This cancels out. So negative 6 with negative 2 is negative 8. I have 8 negatives. I need to divide them among 4 x's each. So I need to divide them by 4 groups. X equals negative 2. Looking at our model, perfect. What are two numbers to the right of negative 2? Negative 1 and 0. What are two numbers to the left of it? Negative 3 and negative 4. And is open dot or closed dot? Closed dot. Number 5, we have, let's model it first. We have 3 x's minus 5. 1, 2, 3, 4, 5 equals negative 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's put an equal sign right here. I need to isolate x. What is the inverse operation of minus 5 plus 5? Let me balance it on the other side. So I add 5 on the other side. 1, 2, 3, 4, 5. These 0 pair out. These 0 pair out. So I have 1, 2, 3, 4, 5, 6. I have 6 negatives. But I need to divide them among 3 x's. That means each x will need 3 negatives. So the answer should be x equals -3. Let's see if this is correct. Let's look at algebraic steps. I need to isolate x. What's the inverse operation of -5 plus 5? I balance it on the other side. So I add 5 to both sides. This cancels out. So I simplify it. 3x equals -6. I have 6 negatives that need to be divided into 3 x's. That means divide by 3. Each x needs 2 negatives. -2, -1, 0, -3, -4, and open dot or close dot because x equal to -2 is part of the answer. And now, what if you are tired of modeling? I'm tired of modeling. Could I do it without modeling? Well, let's see if possible. So here's our answer. So what is the, here's x. I need to isolate x. What's the inverse operation of +5? -5. So I subtract 5 on both sides. This is canceled to 0 pair, and let's simplify it. 1/7 x equals, what's -2 with -5? -7. So you have 7 negatives. However, 1/7 x is equal to that. We want to figure out what x is equal to. If you want to here's our picture. Here is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So each 1/7 x have 7 negatives. This 1/7 x has 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 7 negatives. So entire x is equal to -49. How can I get that? In case you forgot, what is the inverse operation of divide 7? Multiply 7. Multiply 7. This cancels out. So it is x equals -49. And let's plot this on a number line. Is it going to be open dot or closed dot? Closed dot because -49 is part of the number line. Next one. In this example, so we need to isolate x. So we subtract 1 from both sides. This cancels out. And let's simplify this. 2/3 x equals -8. So we have 2/3 x equals -8. So what is the inverse operation of multiply? It is divide. When you divide 2/3 by 2/3, how would you solve this? You would have to multiply by the reciprocal in order for it to cancel out to become one whole. So to get rid of this, you will be multiplying by the reciprocal. What is the reciprocal of 2/3? 3/2. Would this cancel out? Yes. 6/6 is one whole. That would cancel out. So let's balance it on the other side. So you're multiplying by its reciprocal. So it cancels out. X equals -24 over 2 is -12. So x equals -12. Let's graph this. Whoops. Open dot or close dot for -12. Again, what did I do? You may have gotten confused by here. So what I did is I isolated x by doing the inverse of +1 with -1. So I subtracted 1 from both sides. So I got 2/3 x equals -8. I want to isolate the x. What is the inverse of multiply? Divide. So I'm dividing by what? 2/3. Again, how do you divide fractions? You have to do the reciprocal. So these cancel, getting 6/6 is one whole, and that's how I got that. Let's try our last example, number 8. And this one was the inverse operation of plus, on the isolate t, the inverse operation of 3.5 or 3 and 5 tenths is subtract 3 and 5 tenths, subtract 3 and 5 tenths from both sides. This cancels 0 pairs. So I need to simplify. If you subtract this, you get 12 minus 3 is 9 whole. So I have 9 positives that need to be divided into 4 groups. This cancels. So t equals 9/4. Actually, 9/4 is perfectly okay. I cannot say that is wrong. In upper math, that would be acceptable. Another way to say it is 2 and 1/4 or 2 and 25/100 because 4 go 9 2 times. So if you want to, you can graph 9/4. This could be 10/4 and this could be 8/4. And that is our last example. So